Hi all, in this presentation I'm going to discuss what is Liskov Substitution Principle with real world examples. It is also called as LSP. So your object oriented programming skills are at par and now you want to apply your knowledge to live projects. After all, understanding the four basic pillars of OOPS like polymorphism, encapsulation, data abstraction and inheritance, also knowing a few cool things like constructor chaining and static methods should be enough to pull off the job, right? Well, sorry to disappoint you, but a solid wall awaits. Knowing the basics is one thing, but writing good quality code is another. This is where the five most important software design principles come into play. They are single responsibility principle, open or closed principle, Liskov distribution principle, interface segregation principle, dependency injection principle. Out of these, the most important and the most misunderstood principle is Liskov substitution principle. Well, guess what? The gods of YouTube has landed you on the right presentation because in this presentation I'm going to talk all about LSP. So hope on us this will be the only presentation you will ever need to understand the infamous LSP. Here I come up with the definition of LSP. It states that the object of a superclass should be replaceable with objects of its subclasses without breaking the application. In other words, what we want is to have the objects of our subclasses behaving the same way as the object of our superclass. So, the next time when you create an object, subclass by mistake, you should still be fine. But Tamarai, what does this even mean? How can an object of another class behave the same way as another's? You might ask me. Let me give you a real life example and it will be crystal clear to you. Remember in 5th grade when your maths teacher taught you the formula of area for rectangles and squares, I always remembered squares as the more formula friendly to rectangle. It is after all a rectangle with equal sides, isn't it? Now, suppose you have a base class rectangle and I tell you to create a new class square and maximize reuse. Will you inherit the rectangle class instead the square class? No matter how tempting it might sound or how well you intend to handle it, this small reuse will be totally wrong. Let me go with an example. Just go through it by a minute. By looking at the above scenario, you might still argue that it looks pretty consistent. That is true for the language you are coding in and also for mathematics, but a square might not always satisfy the behavior of rectangle. This is what I mean. Squares might not always satisfy the behavior of rectangle. Your client method expects a rectangle and asserts a value of the area. All was well up to this point. But now when we do rectangle.setHeight of 4, our square will set both its sides as 4 and that will totally mess up with the assert statement. We were expecting a rectangle of size 5 and 4 to have an area of 20, but we got a square with side 4 and 4 and area is 16. Hence, using squares object in place of the rectangles object totally breaks LSP. Read the definition of LSP again. Simply put, Liskov substitution principle states that objects of a superclass should be replaceable with objects of a subclass without breaking the application. Here I come up with without breaking the applications. This was just a small example. There will be numerous other problems if you plan on creating an algebra application inheriting a square from a rectangle. Few more real-life examples. Your landlord wanted you to fix the main gate's light bulb, but you gave him Diwali lights instead. Will he be happy? No, he won't be happy. Crackers light is not the solution. The same, you feed your neighbor's pet duck expired bread and now it's dead. You decide to replace it with a toy duck. Will he be happy? No, sure he won't be happy. This is not the solution. A doll duck is not the solution. Hereby I conclude that the Liskov Substitution Principle is one of the 5 solid principles of object-oriented programming. All the 5 principles combined are helpful in making object-oriented code more readable, maintainable, and easier to upgrade and modify it. If this presentation helped you understand the concept, then do spread the knowledge. Share it with your friends and colleagues. If you want to learn more about all the 5 solid principles, then stay tuned. Thank you.